Solve the log of 3 plus twice the log of x is equal to the log of 1 minus 2x for x. In this particular case, there is no base given on the logarithm, so the default is this is log base 10, which is the common logarithm. First thing you can do is use one of the logarithm rules, and this 2 right here can get drawn up into the exponent. So let's do that as a first step. Log of 3 plus the log of x squared is equal to the log of 1 minus 2x. A second law of logarithms tells you if you have the log of one thing plus the log of another thing, that's the same as the log of their product. So this would be the log of 3x squared is equal to the log of 1 minus 2x. Now, the whole reason we were doing these two steps, namely bringing the 2 up into the exponent and combining these two logarithms, is now we have the log of one thing is equal to the log of another thing, which means 3x squared must be equal to 1 minus 2x. So this becomes 3x squared is equal to 1 minus 2x. This right here can be recognized as a quadratic equation. What we'd like to do is we'd like to get a 0 on the right-hand side. And so in order to do that, we want to subtract 1 minus 2x from both sides of the equation. Well, starting with the left-hand side, when you subtract 1 minus 2x from both sides of that equation, at least from the left-hand side, you get 3x squared plus 2x minus 1. And when you subtract 1 minus 2x from the right-hand side of the equation, you get 0. So there is a quadratic equation. We can solve this in one of three fashions. We can solve it by factoring, or completing the square, or the quadratic formula. Let's see if this factors first, because that's usually the easiest way. There's a 3x and an x. This one has a slightly more complicated sign pattern because there's a plus and a negative here. So fortunately, there is a 1 right here. So we can put a 1 here and a 1 here if it is going to factor. And we know that when we multiply these two here, we get 3x, and here you get 1x, so we can get these to 2x by simply putting a negative here and a positive there. So this is the same as saying 3x minus 1 is equal to 0, or x plus 1 is equal to 0. Solving the first of the equations, you add 1 to both sides of this equation. When you add 1 to the left-hand side, you get 3x. When you add 1 to the right-hand side, you get 1. To solve that equation, you divide both sides by 3. When you divide the left-hand side by 3, you get x. When you divide the right-hand side by 3, you get 1/3. So that's one of the solutions. How about the other one? To solve this equation, you subtract 1 from both sides. When you subtract 1 from the left-hand side, you get x. When you subtract 1 from the right-hand side, you get -1. So our two solutions here are x equals 1/3 and x equals -1. However, if you look up at the equation up top here, you'll notice that if you were to plug x equals -1 in here, you would be taking the logarithm of a negative number. So for that reason, this solution right here gets crossed out, and we only have one solution to this equation, and that one solution is x is equal to 1/3. And to be on the safe side, we should probably take x equals 1/3 and plug it in to make sure that it works. But it does. We have a single solution, x equals 1/3.